Good evening. I'm Leonie Watson. I'm an accessibility engineer for a company called the Paciello Group, or TPG, based in the United States. And I'm also accessibility lead working with the UK government on the GovUK platform. In my spare time, I also work with the W3C on specifications like HTML and SVG and ARIA. And it's ARIA I'd like to talk about today, and how we can use it to fix some common accessibility problems. And I'd also like to look at a few other accessibility tips and tricks that you can use to fix accessibility or test for accessibility in different situations, different design patterns, and different JavaScript frameworks that we use for development. Before I do that, I want to take a look at accessibility mechanics, how the code you write or we write is used in the browser, what the browser does with it to make information available to assistive technologies. And by assistive technologies, I mean things like screen readers that translate what's on screen into synthetic speech, speech recognition tools that you can use to control a computer or mobile device with voice commands, screen magnifiers that increase the size of content on screen, and a few more besides. So HTML mechanics. When we use HTML, you may not be aware of it, but a lot of stuff happens within the browser without you having to do anything other than write basic, good quality HTML. One of the things that happens is when you choose to use an HTML element, the browser knows what that element is, and it understands what role it fulfills, i.e. what it does. So for example, if you use the image tag, a browser will know that it represents an image, and depending on the platform the browser is being used on, it'll tell assistive technologies that they're dealing with a graphic or an image. So for the example that's on screen now, a screen reader would just announce this is a graphic, and then it would announce the alt text, Chimuco's tequila. And it makes that information available to the user, so the user knows what kind of content they're accessing. Another example is the HTML5 main element. And the browser knows, again, that this element represents the main content area on the page. And it makes that information available to assistive technologies. So a speech recognition user can move to the main content area of the page. A screen reader user will know that that's the part of the page they're on. Screen readers also do something pretty clever with the main element and other HTML5 elements like section, article, aside, header, footer, and nav. And they use them as navigation landmarks. So screen readers have shortcut keys that mean you can move from one of these landmark elements to the next on the page. And when you do, you'll be told what part of the page you're in. So if I use my screen reader to move to the main content area, as soon as I do that, the screen reader says main region, or main content area, depending on which screen reader I'm using. There are a couple of exceptions to this rule, though. When you use span and div elements, the browser doesn't really identify them as having a particular purpose or a role, so we call them semantically neutral elements. So this basically means that when you use them, there isn't any information made available to assistive technologies about what you're using them for. So with the examples on screen, a screen reader or a speech recognition tool would just recognize the content as plain text and nothing more or less than that. So when you think about building custom widgets and repurposing these elements to do other things, like become sliders or tabs or buttons or links, it's really important to think about the fact that natively the browser will still just think they're plain spans and divs with no more purpose than that. The browser will also recognize the accessible name for different elements and content on the page. A name is just something that differentiates one element of its kind on the page from any other. And you can get accessible names for elements and content in 2 or 3 different ways. With a link, for example, the accessible name is taken from the content of the anchor tag, in this case, Tink UK. And it's that link text that tells this link apart from any other. So a speech recognition user could target this link by saying, click on link, Tink UK, and that link would be activated. A screen reader user would hear link, Tink UK, and would again know what they're dealing with and what kind of content it is. You can also get an accessible name from an attribute. Again, looking at the same image example that we had before, it's the alt attribute that gives this image its accessible name. And I said before, the screen reader would announce graphic Chamuco's tequila. And it's that Chamuco's tequila that tells me what's in this image and enables me to refer to it next time I want to maybe focus on it, or if I were a speech recognition user, to target it in some way. You can also get an accessible name from an associated element. So in this example, we've just got a label element that's paired with an input element, and it's the string inside the label that gives this particular form field its accessible name. So when a screen reader focuses on this edit field, they will just hear the label text spoken, and that's how they know what this field is, or at least what information is expected of them when they enter stuff into this field. The browser also makes information about the state of elements available to assistive technologies. So for example, if you use the checked attribute, then that information is communicated by the browser to assistive technologies. Can then tell the user. So a screen reader user focusing on this will know that this checkbox is in the checked state. A speech recognition user can also use that information to uncheck it. Another example would be the required attribute. When you use this on a form field, again, it just makes that information that this form field is required, that you must fill it out before you can move on and complete the rest of the form. You team this up, obviously, with some visual styling to indicate it was required, perhaps an asterisk or even the word required. But for someone who can't see the form, like a screen reader user, this attribute state is communicated as well at a programmatic level. Something else the browser does is handle focus and keyboard interaction for you. When you use certain interactive elements in HTML, the browser automatically knows that, as well as mouse functionality, keyboard functionality needs to be provided. So for example, if you use an anchor element with the href attribute, the browser will automatically make it focusable. So if you use a tab key, not a mouse, to move through your content, you can tab onto a link and interact with it. The browser also knows that it should be possible to activate a link using the enter key, and it provides that handling automatically for you. Similarly, if you use something like a button element, the same is true. The browser will automatically make it possible to focus on it with a keyboard, and it will also provide the interaction. In this case, the expectation is that you'll use either the space or enter keys to action a button, and the browser just provides that behavior for you. So the lovely thing about using HTML is that from an accessibility point of view, a lot of the hard work is done for you. And people often say that accessibility can be difficult, and sometimes it can. But the best thing you can do for accessibility in the first instance is just use HTML as it was intended. So use the right element for the job if it's available, and let the browser do all the hard work for you. So the question is, the browser's making all this information available to assistive technologies. How do assistive technologies get at all the information? Well, the answer is platform accessibility APIs. There are APIs available on all platforms. On Windows, it's MSAA, UI Automation, and iAccessible 2. iAccessible 2 is also available on Linux. OS X has the NS Accessibility Protocol, and Android and iOS also have platform accessible APIs that assistive technologies can use to query information about the content that they find on screen. So, for example, if we took a checkbox somewhere in an operating system, this one is from Windows 10, somewhere in the control panel, if an assistive technology like a screen reader were to use one of the platform accessibility APIs to discover some information about it, they'd be told that it has a role of checkbox, that its accessible name is bold, because that's what the checkbox lets us toggle between, and that its state is focused, focusable, and checked. And that information can all be communicated by the assistive technology back to the user. If we create the same control on a web page, just using standard HTML, exactly the same information would be available through the same API. We'd know that this was a thing with a role of checkbox, an accessible name of bold, and that its state was focused, focusable, and checked. And the nice thing about the APIs is that no matter where a control is, whether it's in the operating system, an application interface, or in a web page, the information that's available to assistive technologies is pretty much the same. And so it creates the opportunity of a very consistent experience for users. all of these relationships between the operating system level or the platform level and content in web pages is being mapped by the W3C. So if you want to know how a browser views different HTML elements, what it thinks the default roles for different elements are, information about states and properties, it's worth checking out this document from the W3C because that's where all these relationships are being mapped, and it's really useful information to have in order to understand accessibility mechanics and the way HTML works. So how does the browser deal with all of this information? We're still missing a piece of the puzzle. When you load a document into the browser, it creates a document object model. It's just a hierarchical representation of all the nodes and content in the page. What you might not know is that the browser also takes some of that information from the DOM and creates a separate tree called the accessibility tree. And this is information about all of the nodes within the DOM, but specifically about accessibility. So the accessibility tree in the browser is where you find all the information about the roles and states and accessible names and descriptions and all the other information that you might want to know about the accessibility of some content. And it's these accessibility trees in the browsers that are queried using the accessibility APIs. The question of how we access the APIs and how we get at that information in the accessibility trees isn't quite as simple as we'd like it to be, though. At the moment, you can't use JavaScript to access the information in the accessibility tree or to interact with the APIs. It's something that a new working group at the W3C plans to work on, a way to script accessibility access to the browser, but for now, it simply isn't possible to do it using JavaScript. It is possible for us to use ARIA to change the information that's in the accessibility tree, though. ARIA is Accessible Rich Internet Applications. Version 1 of the specification was released last year by the W3C, although we've been using it for a lot longer than that. And we're currently working on version 1.1 of the spec, which is mostly bug fixes, but introduces 1 or 2 new features as well. And ARIA basically is a set of attributes that you can use to add to HTML that will either change or override or update the information the browser makes available in the accessibility tree. There are lots of roles that you can apply using the role attribute. There are more than 30 of these defined in the 1.0 specification. There are roles for lots of things that we build on a regular basis on the web. Sliders, dialogues, checkboxes, radio buttons, toolbars, menu bars, and a whole bunch of other things beside. And these roles are very useful when we build custom widgets. And I'll show you an example of how we can do this in practice in just a bit. The ARIA specification also includes a number of attributes that let you define the state of an object. All ARIA attributes start with ARIA and then a dash, and then the actual attribute name, just to make it easy as a way to separate them from standard HTML attributes. And in terms of states, there are attributes for ARIA pressed, ARIA checked, I think 9 in total. So when you're creating custom elements and custom widgets, you can help make that state information available through the browser to assistive technologies. And there are a lot of different properties, more than 20 different properties, again, all with ARIA-attributes. And there are ARIA label and labeled by, which you can use to create an accessible name, ARIA described by for creating an accessible description, ARIA has pop-up, and lots more besides that you can use to define different characteristics about the widgets that you're building. Before I go on to an example of how we can use ARIA in a practical sense, I just want to mention a couple of constraints about ARIA. One is that it doesn't change the DOM at all. So the code you interact with your script at that point remains exactly the same. When you change anything in the DOM, what happens is the browser will automatically update the accessibility tree accordingly, and that triggers an event that tells assistive technologies they need to look for changes or differences in the code. The reason for this is that ARIA is very assistive technology specific. Actually, even worse than that, it's almost exclusively available to one kind of assistive technology, screen readers. Some speech recognition tools do have limited support, but by and large, it's screen readers that are the primary target of ARIA. Now, people who use screen readers can't see. So ARIA doesn't really have a visual representation on the page. If you add it to your code, there's no easy way for you as developers to know that ARIA has been added, let alone whether it's been working or not. And that can make learning it and implementing it a little bit difficult. There is a recent bookmarklet tool that's been released, and I recommend that you go take a look at it if you're interested in using ARIA. It just uses CSS to visualize on the page where you've added ARIA roles, and as you interact with custom widgets and components, it also uses visual styling to tell you whether those interactions are updating the ARIA as expected. So it's a good way to know if A, you've put things in the right place, and B, they're working as you expect them to when you actually use the content. So let's take a look at a practical example of all of these ARIA roles, states, and properties, and a little bit of scripting and CSS as well, to explain how we can make a custom widget much more accessible than it might be at first. We're going to create a disclosure widget, so just a button that when you click on it, displays some more content on the page, and if you click on it again, hides it out of sight. And our building blocks for this are a span element for the button and a div for the content. It's a pretty standard starting point for a lot of custom widgets. We repurpose these elements because, as I said before, they don't have any real purpose of their own. They're pretty neutral. You'll also see a lot in JavaScript frameworks that controls are built from spans and divs, and that's actually one of the biggest accessibility problems with JavaScript frameworks like Ember and Angular. But for now, we'll just take a look at this particular example. If we were to add in some JavaScript and some CSS to get it all functioning, this is pretty much the experience you'd get if you used a mouse. So it works pretty much as expected. You hover a mouse over the button, it changes appearance to let you know where your focus is. You click on it, it opens the content and closes up again, and everything works just as well as you'd hoped. If you were going to try using the same thing with a keyboard, this is what would happen. Pretty much nothing at all. Because a span is not an interactive element, the browser doesn't do that helpful thing I was talking about before and give you any keyboard interaction at all. So you can't focus on a span if you use a keyboard. And of course, if you can't focus on a span with a keyboard, you can't use it with a keyboard either. So this widget in its current state is pretty much useless unless you use a mouse. Now, if I can switch over the audio feed, too much. I can show you now what the experience would be like with a screen reader. So although screen reader users are almost always keyboard users, we do have a few tricks up our sleeves with screen reader software that let you focus on things that you really wouldn't be able to if you weren't running a screen reader. The upshot is this.
Tequila.
That's it, just the one word, tequila. Because again, a span is just neutral. There's nothing that the browser tells my screen reader and assistive technologies that this is anything other than a piece of plain text. Might look like a button, might function like a button if you use anything other than a screen reader or a keyboard. But to all intents and purposes, if you can't see this and you use a screen reader, it's just a piece of plain text. I'm going to swap this back so you don't have to listen to my screen reader talking at me while I'm giving this, which is, trust me, a good thing. So what we're going to do, we're going to fix it. We're going to use some ARIA, and we're going to start with the role attribute. And we're going to put it on the span, give it a value of button. So now in the DOM, this is still a span, but in the accessibility tree, this is now recognized as a button, and assistive technologies can treat it as such. It's still not going to behave like a button. It just means that screen readers and other assistive technologies that do support ARIA will indicate to their users that this is a button. So we're one step ahead. We've got a role, a purpose for this particular control. We're going to use the tab index attribute, again, on the span, and give it a value of 0. This is going to make it focusable with a keyboard. And we're going to use 0 as a value as opposed to an actual number, because this will just add the control into the tab order of the page based on the element's location within the DOM. So it just fits it really naturally into the normal tab sequence of the page and keeps things moving nicely, so a keyboard user can now focus on this element, so another step in the right direction. We're going to add some focus styles, or rather, we're going to duplicate the focus styles that we have for mouse users and just apply them so that, as well as being available on hover, they're available on focus. Changing the appearance of something when it receives keyboard focus is incredibly important. When you next get to your computer on a website that you use a lot, try using the tab key and not your mouse to navigate through it, and see how quickly you get lost or you can't find where your focus is currently on the page. It's really important to sighted keyboard users that when you focus on something, it pretty much lights up or changes appearance or looks different in some way, so they know with good confidence that when they hit the enter key or the space key, the thing they're trying to interact with is actually the one they want to be interacting with. So here we're just duplicating exactly the same CSS and just applying it with the same selector. We now need to add in some keyboard interaction. So if you can focus it with a keyboard and you know when you're focused on it, we actually need to make it work. And to do that, as well as listening to click events, we're going to listen to key down events. And we choose that event listener because, if you remember at the beginning, I said the expectation for a button is that you can activate it using space or enter keys. So we need to listen for those particular key presses. And the way we do that is by the key codes that are returned through key down event listening. And then what we do is when we hear the 32 or 13 key codes, we can go ahead and ignore all other key presses and execute the function that we want to when either of those keys is pressed. It's really that simple, just to add in this extra bit of keyboard handling that the browser would have provided for us, of course, if we'd used a button element to start with. Back to some ARIA. We're going to use ARIA-expanded, again, on the button. And this just tells screen readers whether the widget is open or closed. So we set it to false initially, and when the button is used and the content is displayed, we set it to true. The screen reader now will just announce that, as well as it being a button, it's either in the expanded or collapsed state. So that's just providing information that visually is very obvious, but if you can't look at the page and you use a screen reader, makes the same information about the state of the object available to you. We're also going to associate some styles with the state. We've chosen to put a small icon on the button here, which will just change appearance depending on the state of the widget. It's generally just sort of eye candy, but it's another way to indicate whether something's working or has changed. And in this case, we're just going to tie the display and the content of that icon using the before and after pseudo selectors to the ARIA expanded state using CSS attribute selectors. So as soon as that ARIA expanded attribute changes its value, the CSS will take care of changing the icon that's displayed automatically. We're also going to use ARIA-controls, again on the button element, and as its value it takes the ID of the div containing the content. When you activate this widget, if you can see what you're doing, it's really obvious when the content opens on screen. You can just see it. If you use a screen reader, it's not obvious at all. Pressing this button could well have changed something just below the button, just above it, somewhere else on the page entirely. You really have no way of knowing. So what ARIA controls does is create that relationship between the two things, between the button and the content. And in the cases of some screen readers, makes a shortcut available, so you can jump your focus straight from the button to the content that's just been controlled by the button. We're also going to add ARIA hidden, ARIA-hidden, and we're going to use it in two different places. First, on the span that contains the icon, because as a screen reader user who can't see the visual display, it's really not that important to know about the icon's presence. What ARIA hidden does is remove the element and its content completely from the accessibility tree. So as far as an assistive technology is concerned, that span element containing the icon simply doesn't exist. It's just not even in the equation at all. We're going to use the same attribute on the div containing the content. In this case, we're going to set it to true initially, because when the widget's collapsed, we don't want assistive technologies to be aware that that content exists. As soon as the widget is opened, then we change the attribute value to false, and that content's re-injected back into the accessibility tree, and it becomes available to screen readers again. And then we're going to use the same trick with styles that we did before. we're going to use the ARIA hidden attribute as the attribute selector in CSS to hang the display styles off. So while the content is hidden in the accessibility tree, we set it to display none, and as soon as that attribute changes, we set it to display block. And so as soon as the ARIA changes, we set off that design cascade, which has two purposes, really. A, it keeps the code really neat and quite easy to maintain, but it also means, from a development point of view, if you accidentally change something that impacts the accessibility, it's really easy to see, because suddenly your design won't work either if the accessibility is broken. And lastly, we just need to add in the functionality that brings it all together. Back to our JavaScript, all we need to do is just set up the function to change the two ARIA attributes, the ARIA hidden and ARIA expanded. As soon as the function's executed and the state of either of those changes, it sets off the design cascade, the CSS changes, and the whole widget works. At least that's what we hope. So what happens if you use a screen reader with all of this? Well, it makes quite a remarkable difference. Remember how it just said tequila before? This is what happens now.
Tequila button collapsed. Tequila button expanded. Use JAWS key plus Alt plus M to move to controlled element. Move to controlled element. Makes me happy ...
So now we've got a whole bunch of information that's available where it wasn't before. The screen reader user knows that they've got a button, that it was collapsed. When they interact with the button, something expanded. There's a shortcut that takes them to the expanded content, and then that gets read automatically. That, coupled with making it keyboard accessible, has completely transformed this otherwise largely inaccessible widget so that it may not be universally accessible, but it's certainly a lot more usable by keyboard users and screen reader users. Another example, another common design pattern are sets of tabs on the web. We see this feature all the time used as a space-saving device. We have a set of horizontal tabs on the page. So the basic HTML for a set of tabs might look something like this. An unordered list with a couple of list items, links inside to create the interactive controls for choosing which of the tabs you want displayed visually, and some divs that contain the tab content. When an assistive technology like a screen reader queries the accessibility tree using the APIs to find out about this content, they're not going to see all the visual styling that make it look like a horizontal set of tabs. They're just going to find out about the HTML elements, that it's a list with some items of links and there's some content below it. And that makes it really difficult to know how to interact with it. So we need to fix the information that's available to people who are sighted in such a way that it's available to people who can't see what they're looking at. So it won't surprise you to learn that we start with a role, actually, several. The first is the tab list role, and we apply this to the UL element. So now, instead of hearing that there's a list containing a couple of items, a screen reader user will hear that there's a tab list containing a couple of items. So we're starting to set up the expectations for the type of content that we're interacting with. We're going to add the tab role using, again, the role attribute on each of the links that represent the tabs. So these now stop becoming links and actually become tabs. There's still something you can click on, still something you can interact with, and if you've provided the keyboard functionality in your JavaScript, something you can use with a keyboard. But the information a screen reader user is aware of, again, just changes slightly to help them understand the type of content they're interacting with. We add the tab panel role, and we do this to the divs containing each of the panel contents for the tabs. And again, this just overwrites the semantically neutral div element and says, instead of just ignoring this and treating it like plain text, let users, screen reader users, know that it's content for a tab. It's just a tab panel. We're going to add the presentation role to each of the list items. Presentation role basically says to a screen reader, this element isn't important, it's just presentational, so you can pretty much ignore it. Now you might be asking why we bother using that on a list item, why not just get rid of the list items altogether? And that's just basic good progressive enhancement technique. If someone's using a browser or technology that doesn't support ARIA, they're going to need that old-fashioned HTML information underneath it. So although it's not perfect, knowing it's a list with some items containing links is still useful information if you haven't got access to the ARIA enhanced version. We're going to use the ARIA-selected attribute, and we use that on each of the links that represent the tabs. For the one that's currently selected, so the one that has its tab panel displayed, we set the value to true. For all the other tabs in the set, we set it to false, and this gets updated dynamically through the scripting so that whichever tab has been selected, that's the one with the attribute set to true. And this just tells screen reader users which tab has been selected, so as they focus on it, they'll be told that it's either, and I forget which, the Blanco or the Reposado tab that has been selected. Again, just making information available that's obvious to a sighted person, but not available if you can't see the page. We're going to use the ARIA-controls attribute again, and we're going to use it in exactly the same way for exactly the same purpose, to create a relationship between a tab and the thing that it controls. So again, it just takes the ID of the div for the corresponding panel. So when you click on a tab, you've got an easy way as a screen reader user to jump into the tab panel contents that you're interested in. We're going to use the ARIA-labeled by attribute, and this provides an accessible name for the tab panels. And we do it by giving the ARIA-labeled by attribute the ID for the corresponding tab. So this kind of works in a slightly different way to ARIA controls. ARIA controls says this tab and this tab panel are related. ARIA labeled by says this tab panel has the same name as the tab you used to click on to display it. So it just means that the tab panel for the Blanco tab would be Blanco tab panel, and the Reposado tab would be Reposado tab panel. And again, screen readers just make all this information available to their users. We use ARIA-hidden in the same way we did before, just to make sure that the panels that aren't selected aren't available to assistive technologies. So we set ARIA-hidden to true on all the panels except for the one that's currently visually displayed, and that's set to false. And again, that gets updated dynamically through the scripting. So only one is ever set to false and all the rest to true. And I don't have, unfortunately, an example for that that I can play at the moment, but the upshot is that when you use a screen reader to access that, instead of hearing that you're talking about a lot of list items and links and blocks of content, you now get told that you're dealing with a tab set that contains 2, in this instance, tabs. You get to know which of those tabs is selected, and you get an easy way to jump from that selected tab into the tab panel content. And when you do, you're reassured, because of the accessible name, that you're in the right area of content, because it links the same name as the tab that you chose. So again, with ARIA, what we've done is just made a lot of information that's otherwise visually available on screen, available to people who can't see it. And that's the great strength of ARIA as it stands at the moment. ARIA does have its weaknesses, and I believe Charles will be talking more to that later. But for now, this is the value that ARIA gives us at the present time. I also wanted to talk some about ARIA and some of the JavaScript frameworks that are in popular use today. JavaScript frameworks are an interesting thing. From a development point of view, they're incredibly useful. They let us do very rapid application development. They also remove some of the need to actually understand browser mechanics and accessibility mechanics. And they also introduce quite a few accessibility problems along the way, unfortunately. Some of them are actually really avoidable. JavaScript frameworks, particularly Angular, have a tendency to forget that HTML exists in a lot of respects. So instead of using a link or an anchor element, they'll repurpose a span and do it the hard way. So there's some things we need to look out for and to test for in terms of the different frameworks that we use. They're not perfect. Sometimes you've got to do a lot of manual work if you're using a framework to get it really accessible. There are ways to do it in pretty much every framework that's out there, but it does take quite a lot more work. And that kind of undermines the beauty of these frameworks in the first place. You can really easily develop something, but then actually the hard work's just been transferred to making it usable by lots of people. Good news is there are some tools that you can use to help do this. There is an Ember A11y test suite. If you're not familiar with the term, we use A11y in the same way that we use I18n. There are 11 characters in the word accessibility between the A and the Y, so it's just a shortened way of referring to accessibility. And you can run full tests with the Ember test suite. You just call it into one of your assertions, and if you're running the full test suite, what this will do is run all the tests that are available, and if they all pass, it will just return OK. So it's a pretty straightforward way to be able to assert against something and take action accordingly. With the Ember test suite, you can also run individual test test suites. You can just choose from a whole range of different tests that are available, just pass that test to it, and it will just post messages to your console, or you can get it to flag warnings in other ways if you choose. And it's just worth building this into your dev tools and just getting into the habit of running this if you're building Ember apps. It has to be said, actually, that Ember is one of the better frameworks in terms of accessibility. It's still not perfect, but it's not quite as bad as some. So if you're developing in that, you'll have an easier time of it getting things to be accessible. React also has an A11y test suite. This one functions broadly in the same way that the Ember one does. You can run a full test suite just by calling the npm through as a dependency on the app. And again, that sort of functions in pretty much the same way. You can use it to verify tests and adapt your coding or make changes accordingly. The nice thing about the React test suite is that you can actually get it to filter tests based on the device that you're testing on. So in this case, we've just told it that the device we're using is mobile, and it'll adapt which tests are run based on that, as opposed to desktop. And that makes it quite a neat way, if you're developing responsive designs, particularly, to stay on top of accessibility right across the different modes of the design. Tnon is a slightly different tool. Tnon is an API, an accessibility API, that also has a web-based checker. But people have built tools for incorporating the API into build tools like Grunt and Gulp and a few others besides. Tnon is developed by my friend and colleague at TPG, Carl Groves, and his view on accessibility, like many others, is that it's as much about usability as accessibility. So when you use the Tnon API, you get a certainty score. And this is a really useful technique. It gives you information about how certain the issue is, because sometimes accessibility can be a little bit of a gray area. But it also gives you a good rating on how much of a certainty it is that that particular issue is going to cause problems for users. And that's the really nice thing about it. It takes something that's quite a technical, cold-blooded check, if you like, but keeps the users sort of firmly in mind, which is one of the reasons I think it's a good tool, apart from the fact that it's developed by a friend of mine, of course. So if you're going to use it with Grunt, there is, again, a package available for doing this. You just call it in as a dependency on the application that you're building or your DevTool environment, and you just add that into your Grunt file. It's pretty straightforward. There's a whole bunch of configurations that you can use. The one on screen is just very, very simple. It just pulls in the Grunt tool for Tnon and says, run a AA accessibility check on it, in this case on the home page. If you're not familiar, the AA refers to the middle level of 3 accessibility levels covered by the Web Content Accessibility Guidelines of the W3C. And AA is the target most websites aspire to, and it's also the level of accessibility most commonly referred to by different pieces of law and legislation and policy around the world. And this will just return a lot of information about any number of accessibility checks. It's a fairly comprehensive Web Content Accessibility Guidelines check. It's actually probably the most comprehensive out of all the tools I've mentioned so far this evening. You can also get the Grunt tool to do things like change the viewport size as well. So again, you can get it to trigger responsive modes and check those pretty easily as well. The last thing I want to mention is a package called ARIA, which you can use with Angular. This isn't a testing tool. It's actually a tool you can use to inject ARIA relatively easily into your Angular code without diving around trying to actually get your hands dirty in the code under the hood itself. So it's just a package that you just need to make as a dependency, just call it in as required in your Angular application. And once it's there, it gives you access to several directives that let you inject ARIA into the code for all sorts of things, dealing with situations when items are disabled or interactable, keyboard focusable. There are 7 different directives included in this, and they're reasonably comprehensive. They're not going to fix all of the screen reader accessibility issues that you might want to, but again, it's a pretty good start. So for example here, where you're just using one of the MD checkboxes in Angular, you can just add in the ng disabled attribute, and that automatically then gets converted into the ARIA disabled attribute, in this case set to true. So it indicates that the checkbox in question is actually disabled. And of course, going back to what we were saying earlier, when a screen reader user comes across this checkbox now, they will actually know that it's in the disabled state, i.e. they can't interact with it. There are other directives, as I said, and they're pretty good at filling in for things like keyboard focus, again, injecting tab index, using ARIA states like ARIA pressed to indicate when a button's been pressed, checked, disabled, and lots of other things. So if you're working with an Angular application, it's definitely worth calling in ng ARIA and using it as much as possible, because it will solve a good number of the basic problems that Angular has with accessibility. And that, I think, is me done. So thank you.